If you could travel back in time 250 million years, you would not recognize the Earth. Every continent was fused together into a single enormous landmass called Pangaea, surrounded by one vast ocean. Africa was wedged against South America like a puzzle piece. India was attached to Antarctica. North America, Europe, and Asia were joined in a continuous band of land stretching from pole to pole. There were no Atlantic Ocean, no Mediterranean Sea, no Himalayas. Dinosaurs could have walked from New York to Paris without getting their feet wet. The man who first proposed this idea was ridiculed for it. In 1912, German meteorologist Alfred Wegener noticed that the coastlines of South America and Africa fit together almost perfectly, and that identical fossils of ancient plants and animals were found on continents separated by thousands of miles of ocean. He proposed that the continents had once been joined and had slowly drifted apart over millions of years. The scientific establishment dismissed him brutally. Geologists demanded a mechanism. What force could possibly move an entire continent? Wegener could not provide one, and he died on an expedition to Greenland in 1930, his theory treated as the fantasy of a weatherman who had strayed out of his field. The answer came from the bottom of the ocean. In the 1950s and 1960s, scientists mapping the seafloor discovered a system of underwater mountain ranges, called mid-ocean ridges, that stretched around the globe like the seams of a baseball. At these ridges, molten rock was welling up from the mantle, solidifying and pushing the seafloor apart in both directions. The Atlantic Ocean was literally growing wider by about 2.5 centimeters per year, roughly the speed at which fingernails grow. This process, called seafloor spreading, was the engine Wegener had been missing. The Earth's outer shell is not a single unbroken sphere, but a mosaic of enormous slabs called tectonic plates, about 15 major ones and dozens of smaller ones, floating on the semi-fluid mantle below like rafts on a slow-moving river. These plates carry the continents and ocean floors on their backs, and they are in constant motion, driven by convection currents in the mantle where hot rock rises, spreads sideways, cools, and sinks back down in a cycle that has been running for billions of years. The continents do not plow through the ocean floor. They ride on the plates like passengers on a conveyor belt. Where plates pull apart, new crust is created. The Mid-Atlantic Ridge is a divergent boundary where magma fills the gap between the separating North American and Eurasian plates, building new ocean floor molecule by molecule. Iceland sits directly on top of this ridge, one of the few places on Earth where you can stand on the boundary between two plates and watch the ground literally tear itself apart. Hot springs, geysers, and volcanoes line the rift, powered by the magma rising from below. Where plates collide, the results are catastrophic. When an oceanic plate meets a continental plate, the denser oceanic plate is forced beneath the lighter continent in a process called subduction, diving into the mantle where it melts and fuels volcanic eruptions above. The entire Pacific Ring of Fire, a horseshoe of volcanoes and earthquake zones surrounding the Pacific Ocean, exists because of subduction. When two continental plates collide, neither can subduct because both are too buoyant. Instead, the crust crumples and folds upward like a tablecloth being pushed from both sides. This is how the Himalayas formed, and they are still growing today as India continues to ram into Asia at about 5 centimeters per year. Where plates slide past each other, they create transform boundaries like the San Andreas Fault in California, where the Pacific Plate grinds northwest past the North American Plate. The plates do not slide smoothly. They lock together for years or decades, building up enormous stress, and then release it all at once in an earthquake. The 1906 San Francisco earthquake, the 2011 Tohoku earthquake in Japan, and the 2004 Indian Ocean earthquake that triggered a tsunami killing 230,000 people were all caused by the sudden movement of tectonic plates. The earth beneath our feet feels solid and permanent, but it is a restless machine that has been rearranging the surface of the planet since the day it formed, and it will continue long after humanity is gone.